Hello learners! Welcome to Science 10 Week 1. I am Ma'am Malu Villagracia and I will be your science teacher. Are you ready? Let's start! Module 1 is all about volcanoes, earthquakes, and mountain ranges. Have you heard this word before? Good! What do they have in common? This module will give us the following objectives. At the end of this module, the learners should be able to relate the distribution of active volcanoes, mountain ranges, and earthquake epicenters to plate tectonics. Enumerate ways to ensure disaster preparedness during earthquakes, tsunamis, and volcanic eruptions. And suggest ways by which one can contribute to government efforts in reducing damage due to earthquakes, tsunamis, and volcanic eruptions. Let's have first our review. Let's recall the things that you have learned in grade 9, all about the layers of the earth. So what are the layers of the earth? Can you give me one? That's right, the crust. How about another layer? Good, mantle. And the last one is the core. Let's describe each one. What can you say about the Earth's crust? That's right. It is the outermost layer of the Earth, and it is also the coolest one. It is the layer in which we live. The next one is the mantle. Right. The mantle is the middle layer of the Earth. It is made up of molten hot rocks. The last one is the core. It is the innermost layer and the hottest layer of the Earth. It is subdivided into two parts, the inner core and the outer core. Now, do you remember your lesson in grade 9? That's good. We shall now proceed with our lesson. But first, can you identify these landforms? These are some of the most beautiful places here in our country. Let's identify the first one. What is it? Yes, that is the Taal volcano and it is found in Tagaytay. The second one is Mayon volcano and it is known for having the most perfect cone. It is found in Albay. How about these tiny islands? Have you been here before? What are these? Right, the 100 Islands, and it is found in Pangasinan. I bet you have seen this last one. What is it? Correct. It is part of the Sierra Madre mountain range in Luzon. We will focus this lesson on the lithosphere of the Earth. The lithosphere is the rigid outer part of the Earth, consisting of the crust and upper mantle. When we say rigid, it means somewhat hard and brittle, so it is easy to break. It is composed of the crust on the upper part and the upper part of the mantle. Together, again, they are known as the lithosphere. Now, the crust. The crust is, like we said earlier, the outermost and coolest layer of the Earth. It is composed of rocks and soil, and it is where we live. There are different types of crust. Do you know them? Let us analyze this picture to show the two types of crust. These are the continental crust and the oceanic crust. What have you noticed between the two? Let's describe each one. The continental crust is found under large land masses or continents. It is older, thicker, and less dense than the oceanic crust. The minerals that can be found on the continental crust are potassium, sodium, aluminum, and silicon. It is mostly made up of granite rock. That's why the continental crust is said to be granitic in nature. How about the oceanic crust? As you have noticed, the oceanic crust lies under the oceans. And so there is water on top of it. This water on top of the crust presses down on the oceanic crust, making it thinner and denser or more compact than the continental crust. It is also made up of iron, silicon, and magnesium. And it is younger in nature. Aside from that, it is made up of basalt rock. That's why we can say that the oceanic crust is basaltic in nature. Here are the different continents of the world. Can you name all of them? We have North America, South America, Antarctica, Australia, Asia, Europe, and Africa. In which continent can you find the Philippines? That's right, in Asia. Here is a map of the tectonic plates of the Earth. If you will analyze this, you will notice that the crust of the Earth is not one continuous landmass. It is not one solid landmass. Instead, it is broken into different pieces or segments, and each segment is called a plate. Here you can find different types of plates. You have Eurasian plate, the African plate, the Caribbean plate, North American plate, South American plate, and one of the biggest, the Pacific plate. We also have the Philippine plate that interacts with the Eurasian and Pacific plates. Because of this description, we can formulate the plate tectonics theory. Again, the plate tectonics theory. It states that the Earth's crust is broken into different segments called plates. And these plates move slowly but constantly. This movement is called tectonics. When we say constantly, it means that the plates are always moving all the time, and does not stop. But we cannot notice it because the movement is very, very slow for us to feel and notice. So what if the plates are moving? What are the effects of plate movement? There are three. The first one is, of course, earthquakes, the formation of volcanoes, and the formation of mountains and mountain ranges. For this lesson, we will focus on what is the relationship of the location of earthquakes, volcanoes, and mountain ranges. What do they have in common? Let's have first the earthquake. Do you know what is an earthquake? You have discussed this in grade 9. What is an earthquake? It is the sudden and violent shaking of the ground, and sometimes causing great destruction as a result of movements within the Earth's crust or volcanic action. So in the picture, you see here the effects of an earthquake. What happened to the building? Right, it toppled over. That's why an earthquake is very dangerous because it can cause a a lot of damage to lives and property. Here are some important terms for us to remember about earthquakes. An earthquake happens because there is a fault. A fault is a weak point in the tectonic plate where pressure within the crust is released. When we say fault, there is a crack on the surface of the earth because the different plates that are interacting with each other. And these cracks or fault can sometimes lead to an earthquake when the rocks break underground. This is called the focus. The focus is located underground or under the ground. It is the origin of the earthquake. When we say origin, it is where the earthquake begins. Again, where does the earthquake begin? On the focus. Now, directly above the focus is the epicenter. When we say directly above, it is found on the surface of the earth, above the focus. This is called the epicenter. The point on the ground directly above the focus, and where the strongest vibrations are felt. This means that the nearer you are to an earthquake, the nearer you are to an epicenter, the stronger earthquakes you will feel. And the farther away from the epicenter, the weaker earthquakes you will feel. Earthquakes release seismic waves that travel in all directions away from the epicenter. Everybody say seismic waves. Correct. Seismic waves are waves that travel in all directions away from the epicenter. It means that all the places that surround the epicenter will feel some sort of vibration depending on how near they are to the epicenter. There are two kinds of seismic waves. You have the P waves or primary wave. This is easy to remember. P stands for primary waves. These are the fastest wave, and they will be the first to arrive in a seismic station because they are the fastest. Next is the S wave. S for secondary waves. And they arrive second at the seismic station. How can earthquakes be detected? How will we know that an earthquake has happened? A seismic station is a place where seismologists study about earthquakes and monitor the occurrence of earthquakes. How do they do it? They use a seismograph. Seismograph is an earthquake monitoring instrument which records the seismic waves of the earthquake. So here on the lower part of our screen, you can see a seismograph. A seismogram is a record made by the seismograph. So a seismograph has a roll of paper and a needle which shakes when the ground is moving. And as it moves, it writes on a piece of paper. This paper or record is called a seismogram. Here is an example of a seismogram. So the first to arrive is the P wave. And what is the second to arrive? The S wave. Correct. So where do earthquakes usually happen? Let's analyze the picture. So if we are going to analyze this picture, all the little red dots are earthquake epicenters. As you can see, a lot of places experience earthquakes, but mostly they are concentrated here on the edges of the plates. You still remember the South American plate? If we're going to look at it, you will see that on the edge of the South American plate, a lot of earthquakes are happening. Let's look at the Philippines. Where is it? Here. So the Philippines has the Philippine plate. And you can see that the edges of the Philippine plate is also riddled with a lot of earthquakes or a lot of earthquake epicenters. So we can say that earthquakes usually happen along the edges of the plates or along the plate boundaries. Now let's go to another effect of plate movement, the formation of volcanoes. So what is a volcano? A volcano is an opening in the Earth's crust through which lava, volcanic ash, and gases escape. You have learned in grade 9 that lava is the molten rock that comes out of a volcano. The molten rock inside the volcano or under the volcano is called a magma. And when it comes out, it becomes known as lava. And this lava is very hot and can cause a lot of damage to people, places, and animals. A volcanic island arc is a chain of volcanoes or connected volcanoes that develop parallel to a trench. You can usually see volcanic island arcs in the ocean. So where are active volcanoes usually located? Do all places on Earth have active volcanoes? Let's look at the picture. Again, the little red dots pertain to an active volcano. So here along the edges of the plate, you can see that the volcanoes are concentrated on the edges of the continents. So again, the Philippine plate has a lot of volcanoes. And so does different places as well. So what can you say about these volcanoes? They are usually clustered together along the plate boundaries. So where are they located? Along the edges of the plates. Next, let's have the Ring of Fire. Do you remember the Ring of Fire or the Pacific Ring of Fire or the Circum-Pacific Belt? It is a path along the Pacific Ocean characterized by the presence of active volcanoes and frequent, meaning madalas, earthquakes. So you have frequent earthquakes. In the Pacific Ring of Fire, you can find 75% of the Earth's volcanoes. That means more than 450 volcanoes are found here. And 90% of the Earth's earthquakes occur along its path. So most of the time when there is an earthquake, it's mostly located on the Pacific Ring of Fire. The abundance of volcanoes and earthquakes along the Ring of Fire is caused by the amount of movement of plates in the area. It means that the plates in the Ring of Fire are actively moving as well. And this brings about changes on the surface of the Earth. And it makes the volcanoes more active. And so it means that more magma is coming out in the form of lava. Here is the Pacific Ring of Fire. So you can see along the edge of the South American plate, North American plate, Eurasian plate, and then you have your Pacific plate and the Philippine plate and the edges of an Australian plate. So in the middle is the Pacific Ocean. That's why it's called the Pacific Ring of Fire. Can you see the Philippines? What volcanoes can you recognize here? Yes, we have some of the examples are Mount Pinatubo and Mount Mayon. And also, a lot of other volcanoes in the Philippines are active, like Taal Volcano and Mount Hibok-Hibok in Gimbas. Now, let's go to the final effect of plate movement, the formation of mountains or mountain range. A mountain range is a series of mountains or connected mountains like you see in the picture. The mountains are connected to each other. If there are more than one mountain and they are connected to each other, it forms a mountain range. How is a mountain formed? It is formed by the folding of the tectonic plates. So the tectonic plates are pushing each other and brings the ground upward, pushes it upward, and it forms a mountain. Where can you find mountain ranges? So here in the picture or in the diagram, you have different mountain ranges. So one of the most familiar to you is the Himalayan mountain range. Here you can find the world's tallest mountain. What is it? You know? Correct. Mount Everest. Mount Everest is a part of the Himalayan mountain range. So here. And then on the other side, you have the Andes mountain range in South America and the Rocky Mountain range in North America. Yan. So where can we find mountain ranges? Again, they are usually found along the edges of the plates or along plate boundaries. So in the end, what can we say about the distribution or location of earthquakes, volcanoes, and mountain ranges? Let's look at the three diagrams that we have seen earlier. So if you notice, all of them have the same pattern of distribution. The same pattern, earthquakes, volcanoes, and mountain ranges. They are all correct, located along the edges of the plates or along plate boundaries. The next question is, why? Why are they located along plate boundaries? Can you tell me the reason? Right. It is because along the plate boundaries, the plates are moving. They are moving, and so they are interacting with each other, and they are affecting each other. If the plates are moving, it causes the shaking of the earth, and so an earthquake is formed. If the plates are moving, the magma underneath or the molten rock underneath the plates are disturbed, and they will come out in the form of volcanoes. If the plates are moving, they push against each other, and so it brings the land upwards and forms mountain ranges. Do you see now the connection? Very good. So let's apply what we have learned. What will you experience if you live near volcanoes or along plate boundaries? That's right. You will feel or experience earthquakes. You can also experience volcanic eruptions. And you can also see the formation of mountains or mountain ranges. Now, all of these changes affect us humans, sometimes for the better and sometimes for the worse, sometimes positive, sometimes negative. On the more negative side, these earthquakes and volcanic eruptions can cause damage to lives and property. It can cause a lot of destruction and loss of lives. So what can we do to lessen the damage caused by volcanic activity and earthquakes? That's right. In our school, we do earthquake drills. And these earthquake drills are meant to prepare us in case there is an earthquake. Also, your teachers educate you on how to behave or what to do before, during, and after an earthquake. Also, it is important to learn about the things to do before, during, and after a volcanic activity or volcanic eruption. So all of these measures will help us be safe in times of crisis. So I have here a diagram that is meant to summarize some of the steps that you need to do in order to survive if there's an earthquake or volcanic eruption. Of course, the first plan is to be aware of your surroundings. You have to look at your environment and see what are the risks, what are the events that can happen to you. Are you prone to earthquakes? Do you live near a volcano? After that, you will prepare yourself and your family. First, by ensuring that you have enough water and food in case these events happen. You do this to protect yourself and family. So you plan steps, what you will do in case there is an earthquake. And you plan it and you talk with your family, communicate with your family. Also, you communicate with your school. And this is where the school comes in. It educates us on what to do. And lastly, we involve the community. It's not enough that we know the steps how to be safe. We must teach our community members, our neighbors, so that everybody can help protect themselves, be safe, and also protect the environment and the community. So what are these steps that you're going to do? That will be your task. You will think of ways on what to do before, during, and after an earthquake and volcanic eruption. So I hope that you have learned a lot in this session. You will write your generalization for year number 1 in Padlet. Use the link below to access Padlet, and it will also be posted in your chat pane. So in Padlet, you will write what you have learned by completing year number 1. E stands for explanation, A for application, and R for reflection. In E, explanation, just complete the sentence. I have learned that, then write down what you have learned. A, application, I will apply what I have learned by, then you will write how you will use what you have learned. And letter R, I realized that. What did you realize? What did you think when you were studying this lesson about earthquakes, volcanoes, and mountain ranges? How will you write down your year? Just look for the plus sign here on the lower right-hand corner. the tiny plus sign. Click that and a portion for you will appear. So you will have a tab and that is where you will write your year. If you have any questions, you can ask me later on. That's all for now. You can find me at Facebook and Messenger, Maluta Vara Villagracia, Monday to Friday, from 11 a.m. to 5 p.m. Bye! See you later!